Hi dear students. So in the last class we were learning about what is called as the cis-trans method of nomenclature of geometrical isomers, correct? So in this class we are learning about EZ system of naming. Now I need to ask you why we need two systems of nomenclature actually. The reason for that is with cis-trans system we will be able to give cis or trans if there are identical groups on the same side, or if they are on the opposite side. Minimum one pair of identical groups are required. Now think of a situation across the C double bond C, if the four groups are different types. In that case, how to say whether the two groups are the same groups are on the higher plane or the two same groups are on the lower plane? It is, we cannot distinguish or we cannot say that. In that case, we usually apply EZ system of naming. So I will explain that one more time. For example, in cis-trans system, if you have a C double bond C and I can say here A and here B and here A and here B. In this case, we can say both A are in the upper plane and we call this as a cis system, correct? And suppose we have the other situation. Here we have A and here we have B. In this case, we know that they are on the opposite plane. In this case, we say that this is a trans system. Now, I am talking about a situation where you have A here, B here, and here we have C, and here we have D. In this case, how will you know whether A and D are identical groups or on the above plane and B and C are identical groups or they are on the below plane? We cannot do that because all are different. In this situation, we usually apply EZ system of naming. Now you need to know what is E and what is Z. Now I hope you understood on what occasion we are going for EZ system of nomenclature. Okay, let's see that. Now, what E stands for what actually? E means entgegen. Okay, and Z stands for zusammen. Okay, so E for entgegen and Z for zusammen. Now when you will give a particular isomer as, or when you will designate a particular system as E system, that is what next I am going to explain. So I am rubbing Z, so just I am going to explain E system. So suppose if you have C double bond C here and you have here some A and this is B and this is C and this is D. Assume like all four are different. And in this situation, I am going to assign priority to this one. Okay, so I am going to assign priority means I will assign priority to first carbon that is connected here. That means this is my first carbon across the double bond. To this one I have A and B. So I will assign either this one as high priority or either this one as high priority. Suppose if I am assigning this one as high priority, then surely this one should be what actually low priority, because I am comparing A and B, correct? Now next I am going to compare between C and D, and on comparing I understood that this is high priority and this is low priority. Okay, so next question come to your mind is, sir, how did you arrive at saying that A is of high priority? I can say that there are a set of 4 rules that you need to follow to check whether on comparing A and B whether A is of high priority or not. If you follow that rules, with that rules you can assign priority for A, B, C and D. Now listen, after assigning the priority, how to assign priority I will teach you. Now you just consider after assigning the priority, and if you feel and if you see both high priority are on the opposite side, they are on the opposite side, and both low priority are on the opposite side, in that case we say this system as E system, or it is an entgegen system. I hope you understood. Okay, clear? Any doubts? Now next we will go for zusammen. Okay, so in zusammen it is just the opposite, but we will see that. So let's go for zusammen system. Okay, so next Z, or we say that as zusammen. Okay, So in Zusammen system, again it is the same case. You have a C double bond C, and here you could see A is here, here B is here, and you have 4 different groups C and D is here. Now you have started assigning priority for A, B, C and D. After assigning priority, you understood that this is of high priority. Comparing A and B, you understood this is low priority. Now comparing C and D, you understood this is high priority and this is low priority. Now after assigning priority, when you are comparing, you understood that both high priorities are on the upper plane. Okay, so or both low priorities are on the lower plane. In this case, we assign this system as Z system. Is that clear? You can compare this with Z. Then you can say Sys means on the same side. Similarly, Z, both are is. You can remember like that. Okay, so I hope you understood what is E and Z system. Now the next thing what you need to understand here is how to assign priorities for these various groups. If you understand that, then it becomes very easy to assign E and Z denotation. Okay, so we will see the rules. Okay, so you can call that rule as CIP rule, can involved prelog rules, CIP rules. So I will write here CIP rules for assigning priority. Okay, CIP rules for assigning priority. C for can, I for involved, P for prelog, then can involved prelog priority rules. So basically speaking, there are 4 rules are there. First one we will speak about rule 1. Okay, so what is basically rule 1 stating about? The rule 1 states that priority is directly proportional to the atomic number of the element to which the bond is connected. Okay, I can say one more time, priority is directly proportional to the atomic number of the element to which this sp2 hybridized carbon atom is connected. For example, let me say I have drawn you one example, C double bond C, like this. Now into this I am connecting different system, for example fluorine, chlorine, bromine, iodine. Okay, I have connected 4 different atoms. Now let's see on comparing fluorine and chlorine. Okay, on comparing fluorine and chlorine, tell me who have the highest atomic number. Chlorine has the highest atomic number. In that case, I say this is of high priority. In this case, this will be low priority. Correct? Now, next I am comparing bromine and iodine. Who has the highest priority? Iodine, because it has the highest atomic number. So, this is of high priority and this is of low priority. Now, say both low priorities are on the same side. If you see, both low priorities are on the same side, or both high priorities are on the same below plane. Now both are on the same plane, or on the same plane means they are not in the opposite plane. That means it is a what sort of system? Z system. Correct? This similar to our Sys system. I hope it is clear for you. Now let's see the second rule. So do I need to write the rule 1? So I will write the rule 1 for you so that you can also note down. This is the example. Now let me write the rule 1 for you. I can say priority is directly proportional to the atomic number of the element, which is connected to sp2 hybridized carbon atom. Correct? So here sp2 hybridized carbon atom is which one? For example, in this example, C double bond C, you have chlorine, bromine here. Okay, here iodine. Now if you see here, I am comparing this element. This is connected to a carbon atom. This is sp2 hybridized. So that is called sp2 hybridized carbon atom. Okay, this is a different example. So this is the rule 1. Now can you think of the situation when this rule 1 can fail actually? Now suppose you can assume a situation where I am connecting instead of here. Okay, so just I am connecting here. Here I am connecting CH3, CH2. Here I am connecting CH3. Here I am connecting CH2. CH2, CH3, and here I am connecting CH2, CH, CH3 and CH3. Suppose is this the way I am connected? In this case, what is the problem? I am looking at carbon here, both carbon I am looking, and this carbon is connected to this carbon, and this is also connected to this carbon. This is also connected to this carbon, this is also connected to this carbon. All are connected to carbon atom. In that case, all are having the same atomic number. Then how I can assign the priority? This is the case where the rule 1 fails. Now we need to think how in this case we can handle the situation. That's what rule 2 speaks about. Okay, I hope you might have noted this. Now we talk about rule 2. Okay. Okay. So what is rule 2? Rule 2 states that if rule 1 is failed, then consider the next atom. Okay, I will explain this with another example. Okay, so I will write that rule 2. If rule 1 fails, then consider the next atom. Okay, so with a relevant example you will understand this. Okay, let me write one example for you to understand this. See here, C double bond C, then this is connected to fluorine and this is connected to CH2, CH3. Okay, and the next carbon, it is connected to another carbon which is connected to CH3, another CH3 and another CH3 here. Correct? And this carbon atom, it is connected to which one actually? You can see another carbon atom which is connected to a CH3, another CH3 and another hydrogen atom. Now we will take one by one and assign the priority. Let's see here. Now taking the first carbon atom and seeing here one atom is fluorine, okay, to which the sp2 hybridized carbon atom is connected. So here it is connected to carbon. So here the rule 1 itself we can apply. There is no need to go to the next atom. So we know that fluorine and carbon, who is having higher atomic number? Fluorine. So we say this is high priority and this is low priority. Okay, there is no problem or there is no violation of rule 1. Now coming to the here, we see this sp2 hybridized carbon atom is connected to here also it is carbon atom and here also it is carbon atom. That means with the first atom we cannot identify which is having higher atomic number. So what is the rule 2 stating? If the rule 1 fails, then consider the next atom. So this carbon atom is connected to whom? That is the problem. Here it is connected to 3 other carbon atoms. So we put it in bracket C, comma C, comma C. It is connected to, but always ensure that write it in decreasing order of atomic number. Here all the other 3 are carbon atoms. So all are having the same atomic number. So I am writing it in the bracket like this. Now in this case you can see this is connected to one carbon atom, another carbon atom, then hydrogen atom. So write it in the decreasing order. Then who will come first? First carbon atom, then again the carbon atom, then only hydrogen atom will come. Now as per our second rule, if first carbon atom is failing, we should consider the next atom, but it is having 3 equivalent atoms. So I know I will first compare this C with this one. So here also carbon, here also carbon. So with this one I cannot again distinguish. Now I will take the next one. Here also carbon, here also carbon. I cannot give any distinguish. But now in the third one, here I can see this is a carbon, this is a hydrogen. So this is having atomic number, carbon with atomic number how much? 6, and this is with atomic number 1. So which is higher one? This one. So I can say this is of higher priority and this is of low priority. Now say what sort of system is this one? High priorities are on the upper plane, both are on the upper plane. So it should be what sort of system? It should be an Z system. Clear? I hope you understood the rule 2. Now we will think of a situation where multiple bond is present. Then how we need to consider? That is called rule 3. We will go to rule 3. Okay? So I hope the first 2 rules are clear for you. So we will just consider the next rule, that is the rule 3. Okay. So note down. So rule 3 states that if multiple bonds are present, what will happen? If multiple bonds are present, then consider them as, we will see how to consider them. Okay. So for example, you have carbon, double bond carbon. So in this case, how you need to take it? So you need to consider it like C, single bond C. Since 2 double bonds are there, you need to connect to another carbon also. Okay. So this is the way you need to take it. You need to expand like this. And suppose if it is carbon, triple bond carbon, something like this, C, triple bond C. So how will you consider this one? Now same way you can expand it. Let's see, C, single bond C, to which another carbon connected, and there are 3 pairs coming. Here 2 pairs, here triple bond means 3 pairs are coming. Okay. Now suppose you have a situation where C triple bond N is there. You have a situation. In this case, you can consider this as C, one valency connected to N, another valency connected to N, and another valency connected to N. You can consider like this. All these are examples. We will see one question to understand more of the same. Okay? Then it becomes clear for you. So I will rub this and I will write down the example. Please note down all these things in your notebook, because all these things you need to revise, learn and repeat it. Then only it becomes thorough for you. Okay, and any doubt, please post that in your doubt clearance group. Okay. So let's see that example. Now consider this question where you have C double bond C is there. Okay. Then this is connected to what? First one, it is connected to C triple bond N. Okay, and in the below one you can see it is connected to nitrogen and 2 hydrogen atom. Okay, so the other one, it is connected to a CHO group, so C double bond O hydrogen, and this one it is connected to a carboxylic acid group, so C double bond O OH. Now how will you assign the priority? So again you need to do the same practice. So I know that here first I am going to compare this atom. It is connected to carbon atom and this is connected to nitrogen atom. Who is having the higher atomic number? Of course nitrogen atom. So this is having higher priority and this is having low priority. Correct? Now I am comparing these two. Now here I have the problem. Both are carbon atom. Correct? Here it is connected to C double bond O. C double bond O means it is connected to 2 oxygen atom and 1 hydrogen atom. So it should be O, O, H. Now coming to here C double bond O, OH. That means it is connected to 1 oxygen atom, another oxygen atom, and third one is also oxygen atom. So its order should be O, O. Now on comparing, I understood that here both are same, here both are same, but the last one, this is oxygen and this is hydrogen. So this is having higher atomic number. So I understood this is high priority and this is low priority. So here again low priorities are coming on the same plane, HP are on the same plane. So that means it is an Z system. Understood? So I hope you are getting an idea how to assign E and Z system. Now comes the last rule, that is one of the fun. Now you will think, sir, almost everything is over, right? What is the last rule? Let's think that. Okay, rule 4. I hope all of you are noting down. Okay. Okay. Now coming to the rule 4, I can say if isotopes, what are isotopes? If isotopes, atoms having the same atomic number but different atomic weight. So if isotopes are present, what you should do? If isotopes are present, okay, then consider atomic weight. If isotopes are present, then consider atomic weight. So let's see that. We will see one example to understand that. C double bond C, the one is connected to hydrogen atom and other is connected to hydrogen. What are the isotopes of hydrogen? Hydrogen atom, deuterium and tritium. All these are having the same atomic number but different atomic mass. So here one is hydrogen, other is deuterium, and here you can see one is connected to C double bond OH, carboxylic acid, and to the other one CH3. So can you assign the priority and tell me what sort of system is this? Now I know that here if I am comparing, both are having the same atomic number, that is 1, but I know if isotopes are present, what should be considered? Atomic weight needs to be considered. So deuterium has higher atomic weight compared to hydrogen, so I will assign high priority here and here low priority. And on comparing this one, I understood this is C, both are C, but this one is connected to oxygen, this is hydrogen, so this is of high priority and this is of low priority. Now I am comparing, I could understand high priority, they are on the opposite plane, opposite side. So I know this is a what sort of system? This is an E system, N-Gegen system. Clear? So I hope with this you got a fair idea regarding how the CIP rule is being applied and the 4 rules I have explained. Okay, now let's see more examples for your practice. Let's write one more question and try it out. Okay, so right now we have learned geometrical isomerism in alkenes. Now we have some more geometrical isomerism is pending. So we have learned cis-trans system, we have learned EZ system, and we have some more is there. That's what next we are going to deal with. Before that, we will do some examples and see whether you are thorough with this understanding or not. Okay, so let me write one example and you need to do it. So first one, C double bond C. So into this you have chlorine connected, into this you have CH3 connected, correct? And into this you have hydrogen connected, and into this you have CH3 connected, correct? This is the first question for you, do it. And you have the second question here. So in the next question you could see you have C here and here CH3 here, and you have a hydrogen here, you have a double bond C here. Then next one you have a CH3 here and you have a Cl here. Now try out the third question. So in the third question I will make it little more complicated. So you have a C double bond C here, and into this you have a cyanide group connected, C triple bond N, correct? Then you have a C with the CH3 group 3 times. Okay, CH3 group 3 times, and to the other carbon atom you have one more carbon atom with Br thrice, bromine connected 3 times, and the last one you have CH2I. Now assign this as E and Z system. If you are able to do it, I am sure you have understood this. Now coming to the first one, let's see. Here comparing these two, here it is connected to carbon atom, here it is connected to chlorine atom, higher atomic number for chlorine, and this is of low priority. And comparing this one, carbon and hydrogen, so high priority here and low priority here. Why? Because atomic number of carbon being higher than that of hydrogen. Now you see HP are on the same side, both are on the same side, means this is what sort of system? This is an EZ system. Clear? Now we'll go to the next question. Here if you see, first one comparing, this is carbon, this is hydrogen, so this is high priority and this is low priority. Comparing these two, this is high priority, this is carbon, sorry, I made a mistake. So this is carbon, this is chlorine, so chlorine is having higher atomic number, carbon is less than that, so this is low priority. Now you could see here, low priorities are on the opposite plane or high priorities are on the opposite plane. So what sort of system is that? So this is an E system. Clear? Now we'll go to the third example, wonderful example I will say. Now comparing this is connected to carbon, this is also connected to carbon, fine, but this is connected to triple bond, and that means you have in bracket N, N, N. Now here you have carbon connected to 3 other carbon atoms, so you have in bracket C, C, C. So which one is higher atomic number? Nitrogen. So this is high priority, this is low priority. And on comparing these two, you have here bromine, bromine, bromine. Okay? Because both are carbon atom. With that you cannot find out. So here if I am checking, please note down here. You have 2 hydrogen and an iodine. Most students make a mistake here. Hydrogen, hydrogen, iodine they will write. Don't do that. Write it in the decreasing order. So it should be iodine, hydrogen, hydrogen. Now first one I am comparing. This is bromine atom and this is iodine. Both are different. Which one is having higher atomic number? Iodine. So this is high priority. This is low priority. Now if you see high priorities are on the opposite plane, low priorities on the opposite plane, so it should be an E system. Okay, so I hope you got a fair idea regarding what is Z system of naming. Next we will try to see what is geometrical isomerism in other compounds. Now we have learned geometrical isomerism in alkenes. Now we need to learn geometrical isomerism in oximes, we need to learn geometrical isomerism in azo compounds, and at last we need to learn geometrical isomerism in cycloalkanes. Okay.